Good morning.
Good
Just
morning,
to
Nick. How are
check.
you?
Okay, great. Just would like to check the audio. Good morning, or maybe good afternoon to everyone. I'm delighted to welcome you to our webinar. At Rich Security, we are seeing significant opportunities in this particular region. There is a clear trend of customers transitioning from traditional vulnerability management and manual penetration testing to continuous threat and exposure management, CTEM. This shift is crucial as it enables organizations to stay ahead of modern threats by continuously validating their security posture. At Risk Security, my name is Nick Mo. I'm the CEO of the company. That we are very committed to Middle East market, and we have established a dedicated local sales team led by Mohammed and Rami, who are in this webinar right now. Their expertise and understanding of regional challenges and opportunities will ensure that we are well positioned to support your needs and help you achieve your security goals. I'm also excited to introduce Home, our Global Enablement Officer, who will be leading today's section. Home brings a wealth of knowledge and experience in security validation, and I'm confident that you will find his insights both valuable and actionable. Thanks for joining us today, and I look forward to a productive and engaging section. I leave the floor to Mohammed and Home.
Good morning and good afternoon, everyone. I'm very excited to join this webinar with you and to walk you through the capabilities of continuous security validation using AI agent. So in order to optimize the quality of the audio, I will just go ahead and disable my video, and then we'll get started with our webinar. So I want to start with the current pain points that customers are experiencing. There are basically three pain points. So let's look at each one. The first pain point is that the security staff, in spite of working very hard, they feel that they're not accomplishing much. This is because of the fact that there's tremendous amount of information overload that they have to deal with. Also, on an ongoing basis, they're facing a lot of false positives. For example, if you look at vulnerability scan reports, a number of specific challenges just pop right out. One is that you will see there is a large number of potential vulnerabilities that require to be assessed individually. And then of these vulnerabilities, most of them do not require any action because they're false positive. But in order to realize that, some time and effort is required. And then when it comes to patching, the priority of what needs to be patched is typically not based on whether that vulnerability is likely to be exploited or not. Also, I should mention that despite all the time security staff spends on these vulnerabilities, their exposure risks seem to be continuing to go up. And also the overall number of cybersecurity breaches that we hear about, they are continuing to rise. So that's precisely the reason that the security team feels that they work a lot, but they're not achieving much. The second pain point is that manual security testing is no longer able to keep up with the threat actors, with the hackers. And as a result, the risk window for enterprises is being left open much longer than it should. Why is that? One reason is that the threat actors are also using AI for cyber attacks. As a result of this, the attacks we have noticed have become much more complex in nature, and also they are more effective than they used to be. And of course, they are a lot more frequent than we had ever seen in the past. So organizations that are relying primarily on manual security testing are simply not able to keep up with this ever-evolving threat landscape. So with manual security testing, you would typically have some kind of a budget constraints. And as a result of that, the security testing that is being performed is not frequent enough. For example, it might be once or twice or maybe 4 times a year. Also, security tests that are being performed, they are not being performed across all IT assets, but only a subset of them. So that causes, these two that I mentioned, the first one causes gap in time, and the second one gap in asset coverage. These two gaps, they create a window of opportunity for the hackers, that is the threat actors. And that actually becomes the organization's risk window, which is being kept open for too long. And the third pain point is the ongoing shortage of security professionals. So both enterprise customers and MSSPs feel and experience the impact of this shortage. And this is a problem that is not going to go away. So the solution is not just to wait for more security experts to become available, but it's just to look for alternatives. And that's precisely where an AI-powered solution such as Ridgebot comes into the picture. So what is the solution to the 3 pain points that I just mentioned? So Ridgebot, as an AI-powered automated security validation platform, is able to address all of the 3 pain points that I mentioned. For the first pain point, which is the security staff feeling overworked and also not accomplishing much, Ridgebot helps to bring their attention to business risks that require immediate action. Out of a large number of vulnerabilities, it brings their attention to the ones that need action right now. Also, for the second pain point, which is the risk window being kept open for too long, Ridgebot helps to perform continuous security validation, as opposed to ad hoc security validation as required, for example, by compliance, etc. And for the third pain point, which is the shortage of security staff, security professionals, Ridgebot's AI-powered engine and the automation, they help to address this shortage in a very effective way. Also, it's important to remember that Ridgebot is the first AI agent for security validation. Ridgebot uses expert knowledge to identify and validate the cybersecurity risks. And also, it helps to shorten the risk window from months to days or even hours. So what are some of the challenges of vulnerability management? As you can see in the top graph, the number of vulnerabilities continues to grow year over year. However, as Gartner points out, only 3 to 5% of all vulnerabilities ever get exploited. You can see this reflected by the red line in the top graph. So the bottom graph reflects a very important point. Basically, the score that is assigned to a vulnerability, it does not reflect whether that vulnerability is a candidate for being exploited or not. So as you can see in this graph, the highest number of vulnerabilities that traditionally have been exploited by hackers, by threat actors, they have a score of medium. And the next highest has a score of high. And then the third highest, with a large gap, you see it has a score of critical. Usually, most people think that they should go after critical score vulnerabilities first because they have a higher chance of being exploited. But the numbers are just showing something very different. So that means that the vulnerability scoring should not be used as the main factor for prioritization of the vulnerabilities that require action. So the security staff basically are facing a situation where they have a huge number of vulnerabilities that they are dealing with on an ongoing basis. And there are many false positives in the vulnerability report. And the patching of the vulnerabilities, of all vulnerabilities, obviously is not possible. It's just humanly not possible to patch everything. And prioritizing and patching them in vacuum will not reduce the risk of breaches. So what is the solution? The solution is threat exposure management. So what is threat exposure management? If you take vulnerability management and you sandwich it between attack surface management and validation and security validation, then you have exposure management. That means that instead of looking at vulnerabilities in vacuum, you look at them in the right context. So what is the right context? Basically, it means that you have to ask 3 questions. Is the vulnerability visible by the hackers, by the threat actors? That means, is the vulnerability part of the attack surface or not? Then the next question is the vulnerability exploitable by the threat actors? That's basically what security validation is all about. And the third question is the vulnerability currently being exploited in the wild or not? That is also part of the security validation. So to recap, the main difference between vulnerability management and exposure management is very simple. Vulnerability management focuses on all vulnerabilities that are discovered on cyber assets in vacuum. But in contrast, exposure management focuses on a subset of all vulnerabilities. And what is that subset? These are the vulnerabilities that are both exploitable and visible to threat actors. So examining a large number of vulnerabilities in vacuum will not get us any closer to reducing threat exposure and risk of security breach, as we were just talking about. So I want to take a closer look at the 3 components of exposure management and talk about what is the problem each of these components solve. So the first is attack surface management. Attack surface management addresses the question, what is visible? The next one, the second one, is vulnerability management. It addresses the question, what is vulnerable? And the third is validation. And that addresses the question, is it possible? Is exploitation by a hacker possible? So attack surface plus validation, as I mentioned earlier, provides the right context for assessing vulnerabilities. So what does this right context lead to? It leads to what we call risk mining. So that means out of a large number of potential vulnerabilities that are reported by vulnerability scanners, a small number of vulnerabilities that are identified and prioritized. These are the vulnerabilities that are both visible and exploitable. That means these cause business risk, which means they require immediate action. So you can think of risk mining as finding a needle in a haystack. There are tens of thousands of attack surfaces, thousands of vulnerabilities, and out of these, there are dozens of risks that need immediate attention. And that's precisely where a solution such as RidgeBot, which is AI-powered, can come and perform this kind of risk mining. So let's talk a little bit more about how RidgeBot is able to meet this requirement that I was just talking about. So there is a one-to-one mapping between the components of exposure management and the types of actions that are scheduled by RidgeBot's AI-powered engine, which is called RidgeBrain, by the way. So, so here you see 2 screenshots from RidgeBot showing the 3 types of action types for different jobs that are launched by RidgeBot's AI-powered engine. We have the discover action type, which discovers the attack surface on a given asset. Then we have the scan action type, which detects the vulnerabilities on the same asset. And then we have the exploit action type, which attempts to exploit the vulnerability on that asset. That means to validate that vulnerability. So as mentioned earlier, RidgeBot is AI powered and is as a result of that is able to perform this in an effective way. RidgeBot is able to think just like a hacker, and I will be talking more about that shortly. So we talked about exposure management compared to traditional vulnerability management and why it's important to evolve vulnerability management into exposure management. Now I want to just take a minute to talk about how we can operationalize exposure management. That's where CTEM comes in. What is CTEM? CTEM is a 5-step program defined by Gartner. It stands for Continuous Threat Exposure Management. It defines a framework to ensure that exposure management is successfully implemented in an organization and it can produce good results. So going back to the definition of CTEM, the first word of CTEM stands for continuous. C stands for continuous, and that's extremely important. So discovering the attack surface, detecting vulnerabilities and validating these vulnerabilities should be done on an ongoing basis. That means continuously. And that's actually a great segue into the next slide, which is CTEM and RidgeBot. So RidgeBot is a good platform to help enable your CTEM program. RidgeBot provides a platform for continuous security validation. It makes it easy for security validation tasks to run on a periodic basis, for example, on a weekly basis, monthly basis, even daily basis if needed. In addition, RidgeBot is automated, so no supervision is required. You can just schedule tasks, security validation tasks in RidgeBot, and it will do the work automatically. And last but not least, RidgeBot is AI powered, as I mentioned earlier. It makes smart decisions while discovering attack surface, detecting vulnerabilities, and validating them. So as far as the specific steps of CTEM are concerned, the 3 middle steps can be provided very nicely by RidgeBot. These are the discovery, prioritization, and validation phases of CTEM. So to recap, you can enable your CTEM program using RidgeBot. So RidgeBot's AI agent is a key differentiator. As new information, such as attack surface and vulnerabilities, are discovered on a given asset, the AI agent on an ongoing basis learns from that information, and it digests that information, and then it re-strategizes its security validation plan. For example, what should be the next set of attacks that it should make? It also uses an up-to-date attack library, and I'll talk more about that shortly. And it thinks like a hacker. That's really important. At any given point in time, using whatever information has been discovered up to that point, RidgeBrain, which is the AI-powered engine, decides what to do next, what makes sense to be done next. This is precisely how a hacker thinks. And last but not least, the AI agent automates the entire security validation process. So we've talked about performing continuous security validation as opposed to ad hoc, that is once in a while security validation. So I just want to mention that in order for this continuous security validation to be of any value, it's really critical that it be up to date. What does that mean? That means that it should be able to check for the latest vulnerabilities on an ongoing basis. as we all know, new vulnerabilities come into existence every day. So the platform providing continuous security validation must be updated on an ongoing basis also. It should always be able to reflect the latest vulnerabilities that are out there. Also, there are some vulnerabilities that are currently being exploited in the wild. The security validation platform must check for these vulnerabilities first. These are highest priority. You know, if, for example, ransomware gangs are currently exploiting a particular vulnerability, it's of highest priority to focus on those first. And then it's important that the validation, security validation platform update its attack library on a regular basis, again, to reflect the latest vulnerabilities that need to be validated. So RichBot meets all of these requirements that I just outlined here. RichBot has a plugin library that gets updated every 2 weeks. What is a plugin library? Plugin library is a library of scripts that are used to detect vulnerabilities and also to validate vulnerabilities. So RichBot also uses threat intelligence to track the vulnerabilities that are currently being exploited in the wild. RichBot uses the KEV catalog, which is the known exploited vulnerability catalog from CISA, which is a US federal agency, and it publishes this catalog on an ongoing basis, bringing attention to vulnerabilities that are exploitable and are hot. And also, as I mentioned earlier, the plugin library update of RichBot is every 2 weeks. So that is a lot more frequent than the product update. So that means that RichBot has an extensible architecture that allows this. That's really important. That's a key differentiator. So, so I want to mention that using RichBot, automated security validation is able to stay up to date regarding the vulnerabilities and their attack library compared to manual pen testing. With manual pen testing, is a lot more difficult to stay up to date because the security experts who are performing them, they have to learn about the new vulnerabilities on an ongoing basis, and it's sometimes a challenge. Whereas with an AI-powered engine, with a plugin library that gets updated every 2 weeks, it's much easier to stay up to date. I want to just spend a moment to talk about RichBot's value propositions. There are 5 unique attributes of RichBot. It's 100% automated. The second value prop is that it doesn't require agents to be pre-installed on your assets. The third one is that it validates the vulnerabilities and provides evidence for each one. And also that it can be scheduled to run on a periodic basis, as well as it can be run on demand. That means on an ad hoc basis. And the last one is that it is very easy to operate. So that means no high-skilled personnel is required to run it. RichBot is very easy to use. As I was just saying, you just log into the management console and you start a task, and for example, a pen testing task, an attack simulation task, or you schedule it to run at a later time. The task may run, for example, for half an hour or a couple of hours, depending on the size and complexity of your assets. And then you can see the progress if you have time, or you can just enjoy a cup of tea and let RichBot do the job for you. And, because the entire security testing process is automated, when the task is finished, you log in again to the management console, and at that point you can review the report or you can download the report. So basically you just need to spend minutes with RichBot, and then it is able to reduce days or weeks of manual labor. So that's the power of RichBot. Richbot can do internal testing. Richbot can also do external testing. What does that mean? With internal testing, Richbot is set up inside your network. That means it bypasses any firewall you have. That way, it can find a maximum number of vulnerabilities on your assets and also detect internal users' bad behavior. For example, it can detect weak passwords, weak credentials. Richbot can also be used to perform external security testing. That means it can be set up on the internet, and it would be then pointed towards the internet-facing servers of your organization. In this mode, Richbot will be subjected to firewalls, WAFs, or any other security protection that may be in place. And also in this mode, Richbot is acting just like a hacker. That means it has precisely the same view as a hacker, the external view. In addition, Richbot can also perform lateral movement. That means that after exploiting a target, Richbot can use that particular target, that asset, as a pivot point to go deeper into the network and perform attacks on other assets. That is precisely what a hacker would do. In cybersecurity, it's critical to have complete visibility over your infrastructure, such as your critical assets, critical servers such as Windows and Linux servers, your websites, your applications, cloud, IoT, etc. That's exactly what Richbot is capable of covering. So very wide coverage. So just a very quick set of screenshots to demonstrate what Richbot's advanced technology can offer. On the left-hand side, we are showing a screenshot that shows a SQL injection vulnerability that Richbot was able to detect. And you can see that Richbot is providing actual evidence for that security validation by displaying a list of database tables and database schema. Richbot provides some real evidence for each security validation risk that it reports. We always believe that for each risk, for each business risk, we should provide actual evidence to our customers. In addition, Richbot also shows a complete attack path and kill chain analysis, as you can see on the screenshot, in the screenshot on the right-hand side. So that basically helps you to figure out whether you should change your access policy to close certain ports, for example, or to block the hacking paths and so on and so forth, or actually, patch the vulnerability. So provides all the required information to give that visibility to you. And Richbot provides real-time reports. So while the security validation tasks are running, you can actually view the current status of the pen testing task, for example, by just performing by getting a preview of the report. And of course, when the task completes, you generate a detailed report, and the report includes detailed information about the attack surface, the vulnerabilities that were detected, and also the vulnerabilities that were validated with evidence for each one. And detailed information includes the vulnerability definition, vulnerability remediation, and also the kill chain analysis. So very quickly, I want to talk about some core technologies in Richbot. In this slide, we start at the top right corner, and we go counterclockwise. So Richbot starts its work by performing attack surface discovery first. So it performs asset fingerprinting. It does web crawling. In fact, it uses smart web crawling. And then after that, it moves on to scan for vulnerabilities. It detects vulnerabilities. We actually inject payload in order to detect vulnerabilities, which is different from how vulnerability scanners detect vulnerabilities. And then from there, it moves on to perform validation of the vulnerabilities. That means we actually attempt to see if the vulnerability is exploitable or not. And we if it is exploitable, then from there we perform we move on to perform some post-exploit tasks, such as privilege escalation if possible, and then lateral movement. I want to take just a minute to go over a couple of customer cases, customers who are successfully utilizing Ridgebot and the value that they get from Ridgebot. The first one is Sitcon. Sitcon is a company based in Silicon Valley in California, United States. They provide a mobile payment network, and this network enables global merchants to accept payments from their customers. Sitcon has a very strong presence in AWS. As a financial institution, they have a PCI compliance requirement to meet. So the Pentest report that was generated by Ridgebot was approved by their PCI auditor. But more importantly, Sitcon is a great example of a financial institution that realized that even though compliance takes a lot of efforts, it is not enough to create a secure infrastructure. So they wanted to actually evolve from Pentest compliance to actual security validation. And I should say to continuous security validation, because they saw the importance of performing continuous security validation because their infrastructure was continuing to evolve. So if they just perform, if they passed PCI compliance, then, over the next year, there were so many changes to their infrastructure that that report that was generated 1 year ago, it would be completely out of date. So they wanted to perform continuous security validation. And interestingly enough, this additional security coverage became a selling point for their new customers. So the new customers showed a lot of interest in the fact that they were performing this continuous security validation. And they have a very good quote that I would just read verbatim. They said, "Rich Security has provided great value through its automated penetration testing. It is very innovative and can help the industry to move forward, automating and simplifying the whole penetration testing process." The next customer case that I would like to share with you is Tocumen International Airport in Panama. They have 1,700 employees, a large number of systems to be tested. They range from web servers to data servers, network devices, printers, IP phones. They actually told us any device with an IP address they would like to be able to perform security testing on. And also, they really were interested in being able to prioritize which vulnerabilities to focus on from the huge number of vulnerabilities that were being reported by vulnerability scanners. So, so what they experienced after using Ridgebot was that great time saving compared to manual testing they were performing, and they really liked the effectiveness of Ridgebot identifying the actual actionable vulnerabilities, the business risks, and most importantly, the continuous monitoring of their security posture. They felt it has helped to prevent security breaches for them. So, so I will read the quote from them. They said, "We particularly appreciate Ridgebot's zero false positives. It identifies exploitable vulnerabilities, validates and provides evidence to substantiate those risks. Additionally, Ridgebot's real-time reporting means instant results rather than waiting for weeks." And I will spend a minute to talk about Ridgebot's strategic partnership. So Rich Security has an ecosystem of strategic technology partners. This list continues to grow. In addition to this, Ridgebot also provides a powerful REST API interface that enables integrations with a variety of third-party tools. just to share one example for DevSecOps environment integration, some of our customers are utilizing our REST API to invoke the automated pen testing from their CI/CD pipeline environment. Also, the syslog messages that are generated by Ridgebot are self-compliant. As a result, they can be consumed by a variety of SIEM and SOAR solutions. So, so that is the last slide that I have. I would like to now give you a quick demo of Ridgebot. So here I have logged into Ridgebot, and here we there are a number of security validation tasks that have already that I ran and they have already completed. But I will walk you through the process of creating a new security validation task so you will see how easy it is to do so. So for that, what I'm going to be demonstrating is I will basically perform a pen testing task using a pen testing scenario for detecting whether that particular asset that I will be performing this test on is vulnerable to those vulnerabilities typically used by ransomware attackers. So here I'm creating a task. I'm selecting the ransomware penetration use case or scenario, and I will give it a name, ransomware validation on, and I put the IP address of the asset right here. And I will just say that this is for our Middle East, North Africa webinar. So I gave this task a name, and incidentally, this will become the title of the professional report that gets generated. And then I put the IP address of the asset right here. And now I'm ready to run this. But notice that if I wanted to, I could run it on a weekly basis, monthly basis, daily basis, etc. So let's go ahead and run this. And while it is making some progress, what I will do is I will show you a task that I ran earlier today. This one was on a particular website here. You can see the URL of the website. So perform website security validation. And if I open this, you can see that I go to the vulnerabilities table. You see this table resembles what you see from vulnerability scanners, you know, a list of vulnerabilities. But notice that we have put at the very top of the list those vulnerabilities that have been successfully validated by Ridgebot. And if I open any one of them, we are actually providing evidence. So this vulnerability happens to be SQL injection. The evidence that we provide here is we have the list of all the database table names and also the database schema. We are providing this so that the customer will see there is a sense of urgency. If Ridgebot is able to get this sensitive data, hackers will also be able to get same sensitive data and more. You know, for example, they will be able to get the list of all the users from the users table, you know, potentially sensitive information about each user, etc. So if I clear this filter here, notice that this is the risk table. These are all the risks that Ridgebot was able to detect, business risks. There are 0 false positives in this table. Every single one of these requires immediate action. Again, if Ridgebot was able to detect these, any hacker can also detect them. And if I go to the topology map, here you can see a graphical representation of the attack surface for this particular website, and also the red ones are representing where on those attack surfaces Ridgebot also detected the vulnerability and was able to exploit it. So that means it's exploitable and also visible. When a vulnerability is both exploitable and visible, it's a risk. So going back to our task that we started here, let me go ahead and open it. It has made some progress. We will go to the summary. So notice that what's going on here, the AI-powered engine has launched more than 6,000 jobs. And out of those 6,000 plus jobs, 600, over 700 of them have already completed. What do these jobs do? These jobs do one of these three things. They either discover an attack surface, or they scan for vulnerability, or they exploit a vulnerability. So far, we have discovered an attack surface of size 316. So far, we have discovered 18 vulnerabilities, and we have been able to successfully exploit 4 vulnerabilities. So these are all hot links. If I click on the risks, you can see that we were able to, these are all the vulnerabilities we were able to successfully validate. So notice this one is remote command execution. If I go ahead and open this, we are providing evidence for it. What is the evidence? The evidence is a reverse shell. This is the worst kind of vulnerability you can have. This is exactly what ransomware attackers love. They can get a shell into the device, into the asset, and they can basically take over the asset. So, we are providing similar reverse shell, so you can see for yourself. For example, I happen to see that this is a Linux device. So if I type ls-l, I'm looking at the file system here on the device. As a ransomware hacker, ransomware attacker, I could be copying these sensitive files to the dark web, or encrypting them, etc. So this is very, very serious. Again, if I clear this, here is the number of risks just went up. Now we have discovered 5. So this is there is no false positives here, and our task is still making progress. We are we have a long way to go. I just demonstrate how easy it is to generate the report. Just literally click of a button, it generates a professional looking report. As you can see, this is the report for our MENA webinar, and you can see that it has an executive summary on top. We are showing how many vulnerabilities we have discovered so far, how many of them we have exploited. Here is the breakdown of the vulnerabilities that we were able to successfully validate. Majority of them right now happen to be remote command execution, and then some of them are weak credentials. And then you can see the attack surface information here, like the list of open ports, etc. And then you can see detailed information about each of the exploits. Notice that, detailed information about the exploits, and then kill chain analysis. Step by step, what did Ridgebot do to exploit this vulnerability? So, so we have 15 minutes left of our webinar. I would like to leave it here and open it to questions. So please feel free to submit any questions that you have, and I'll be more than happy to answer. Okay, I see one question. Can Rich Securities product be used to meet PCI audit compliance requirements? Okay, so as I said, in the case of, in that use case, customer use case, the answer is yes. Of course, it depends on the auditor. So Ridgebot generates a detailed professional looking report, as you saw in the demo. So the auditor can review the report. All the information that is needed is included. It is not, by the way, limited to PCI audit. There are other kinds of compliance audit that also Ridgebot can be utilized for. Again, all the required information is included there.
I think one more question is posted here, that what is the major function of Ridgebot? Is it only to test, or it can test, block, and protect? That is a question posted by one of the attendees.
Got it. Very good. So excellent question. So Richbot brings the validates the vulnerabilities. When it performs security validation, it validates them, and then, as you can see here, it provides all the information that you need in order to block the vulnerability. Richbot doesn't block the vulnerability itself. It gives you all the information that you require to do that. And if patching the vulnerability is not something that is feasible right now, for example, for this particular vulnerability, you can see the CV ID right here. Notice that the recommended, the patching is actually to perform an upgrade of the software. And we all know how difficult software upgrade is. It requires planning. Sometimes it may take a few weeks. So the information that is provided in kill chain analysis a lot of times is used to perform what is known as remediation of the vulnerability for the time being. That means you put in place a stopgap solution. You prevent the hackers from reaching the vulnerability until in future you are in a position to perform a proper patching of the vulnerability.
We have another question. Hope the answer works. We have another question that we understand that the solution uses plugins to find vulnerabilities, and these are updated frequently. But what about zero-day vulnerabilities?
Right. That's also another good question. So Richbot does not look for zero-day vulnerabilities. So typically what happens with 0 days is once they become publicly known, and once, for example, a CV ID gets assigned to them, then at that point, once the vulnerability is published, then Richbot, depending on the nature of the vulnerability, either we would try to fit it in our next 2-week cycle of release of the plugin library, or if it is something very critical, then we may actually have an out-of-cycle release of the plugin library. We did precisely that for Log4j vulnerability that a couple of years ago made a lot of noise. And many customers were scrambling to see if they are impacted by Log4j vulnerability or not. So we didn't wait for the 2-week process. As soon as we finished developing the plugins, and we have a number of plugins for that, by the way, then we released them. We released them because our customers were just waiting to perform that validation right away. So again, if it is a 0 day and it is not known to anyone, we are not looking for 0 days. That is not our business. But as soon as the 0 day transitions to a published vulnerability, then we start taking actions. And incidentally, we have a threat intelligence. We utilize threat intelligence, as I was mentioning, and we have a threat research team. We have a team of engineers that focus on nothing but building plugins. So they are constantly looking at the threat landscape and where it's going, and the new vulnerabilities that come into existence, and the vulnerabilities that are being exploited in the wild right now. And also, in addition to that, I should say that we take feedback from our customers. Our customers sometimes request, can you please prioritize such and such vulnerability, or vulnerabilities, sometimes a number of vulnerabilities, and then we do precisely that. So all of these factors are used in order to prioritize which plugins we will be developing, which vulnerabilities we will be developing plugins for.
We got another question as well, that if you can elaborate on the license or subscription mechanism of the product. So I'll just quickly explain here, although Home is there. So we do the licensing part in 2 manners. How we calculate is the number of IPs and the number of web applications. Yeah, Home.
Very good.
So
Very good.
yes,
And also, I want to just add one other point there. We have an end user annual subscription license, which is key. For a given IP address, as Asif was saying, or a website, you can perform as many security validations in a given year as you want. So we just use one license, we consume one license for one asset, for example, for one IP address or for one website. And throughout the course of the year, you can perform as many testing as you want. So that's the power of performing continuous security validation as opposed to ad hoc validation that goes out of date very, very quickly.
Home, I think one question I have missed. Somebody asked that what for EASM, how it works.
Okay, very good. So perhaps I will take a minute and show the external attack surface management feature in the product. So for each of the tasks, for example, for the tasks that I started at the beginning of the demo, if I click on the attack surface table, you can see that we discovered attack surface on that particular asset. So Ridgebot has 3 types of attack surfaces that it discovers. So the first one is the one that everybody's familiar with, basically the list of all the open ports. So on this particular asset, you can see these are all the open ports. And then we discovered what are the services running, what is the service running on each port. And then in addition to that, we also perform fingerprinting. We discovered what is the application that is providing that service on that port. So that's the first type of attack surface. The second type of attack surface is the list of all the websites. So again, on this asset, these are all the websites that are running. And notice that for each website, we report as much information as we can discover. As part of attack surface discovery, we detect what is the server used, the web server technology used. For example, the first one here is using WebLogic. Then you have Apache Tomcat, and you have JBoss, etc. And then if we can detect the language, we have it there. So here you see Java. We also see PHP and Python, etc. And then if a web app framework is used, and we can detect it, we also provide that. For example, notice Apache Struts 2, which is a very popular framework, is detected here in a couple of places here. And notice here, we have a very old web app framework, which is not recommended to be used because it's from JavaSoft and it is not being updated anymore. It's old technology, Java Server Pages, JSP, or Java Servlet. And Ridgebot is able to detect all these and bring to customers' attention so they can take action. Also, Ridgebot has a WAF detection algorithm, web app firewall detection algorithm. And if we detect a WAF, we have that information about it listed in this column. So that was the second type of attack surface. The third type of attack surface is a list of all the get and post URLs. So these are all the URLs that are visible to threat actors. And typically this is the largest table. So I want to go back and show you one other thing that I did here prior to the demo. I perform attack surface discovery on a subnet here. Notice here that the target is a subnet, is a /24 subnet. So if I open this, you can see that Ridgebot was able to discover 43 assets here. So 43 assets were discovered. And if I go to the attack surface table, we are showing for example, the open ports across all 43 assets and the sites across, websites across all 43 assets. Notice the number of URLs across 43 assets is 38,000. So huge number of URLs. And one other important point is that we provide attack surface management, external attack surface management, actually free of charge. it does not consume any licenses. Why do we do that? Because we firmly believe that in security, visibility is the foundation. And we want to help our customers gain that visibility free of charge. So you can first gain visibility. What does my attack surface look like, for example, across my assets in this particular subnet? And then you can choose a particular subnet, say, okay, I want to perform security validation on this subnet. For example, here you can see the list of the 43 assets here. You know, this is a long list, so I'm just selecting one of them here. So this one, you know, the .206. So I can just focus on .206 and say, okay, this is the one that I want to perform a detailed security validation on. So I hope I answered that question. You know, we have a very rich feature set on external attack surface management.
Thank you, Home. Home, we have two more questions. I'll read it out. One, somebody asked whether it is a hardware or an application. So I replied that this is an application, but you can elaborate. And second question, somebody is asking that can one license be used to test a cloud dedicated server, which is hosting multiple websites?
Got it. So let me answer the first question. Yeah, you answered it definitely correctly. It's a software. You know, we provide an image. The software image, you know, the ISO image, for example, can be used to deploy a VM, a virtual machine. For example, if you're using a VMware ESXi or Microsoft Hyper-V, etc., then you can use that image. Or you can use that image to also deploy it on a hardware appliance. You know, sometimes customers prefer to have a hardware appliance. For example, they may have a you know, air gap environment. Then that's an ideal you know, hardware appliance is ideal for that. In addition to these two, we are also present in Amazon Marketplace and also Microsoft Azure Marketplace. Also, we are compatible with Google Cloud. You know, we are not in their marketplace yet, but you know, the image can be deployed in a GCP, on a GCP instance as well. So as far as the second question is concerned, definitely you can perform security validation using ReachBot on your cloud instances. As far as the licensing is concerned, it's the exact same formula that is used if you're not in the cloud. You know, again, we count the you know, for IP hosts, we count the number of unique IPs, and for websites, we count the number of unique fully qualified domain names, FQDNs. So Asif, any other question?
Team,
not-
any other question, or we can, you know, close, you know, any other question? We'll be glad to take that. I don't think yeah. So first of all, I'm really thankful for the valued partner who took their precious time to attend this session. I'm really thankful to Mr. Nick because I know this is a very awkward time to US. I'm thankful to Home as well, who has taken the precious time and given a very informative session to us. In the beginning, Nick has told that what kind of, you know, vision and seriousness we have seeing the Middle East market, and that is the reason that we are expanding our team. I myself is based in the Middle East market. I'm based out of Riyadh, Saudi Arabia. I have you know, in a phase of expanding people team who will be taking care of the business technically. So we are completely dedicated and focused to the territory to develop the market. You would have seen the kind of expertise and the capabilities of the solution, and how important and how critical this solution is to be implemented in the environment. So I think two more questions. I have to stop here. I read this Home. I have to take two more questions for you.
Sure.
So the question number one is Rich Security and IBM introduced integrated SOAR solution? what exactly is the difference in term of licensing, and how we license if we go with IBM Security QRadar SOAR? This is question number one.
Okay, so since we're very short on time, I will just mention that we have an integration with QRadar, IBM QRadar, which is a source solution. And on our website, we actually have detailed information about that, like a deployment guide, so you can easily go there and download that document. And could you do the next question, please?
Yeah, it is. Somebody asked, the server is using one IP, but it's hosting multiple website. How do you scan that? Through the server IP or each website on the server?
Okay, that's a great question. So it is possible for a given asset to be both an IP host as well as a website. For example, the one that I used for this particular demo was precisely that. It had some open ports. For example, FTP port, SSH port were open. In addition to that, it was also hosting website. So then each, for IPs, for all the non-HTTP, HTTPS ports, we will be consuming one license. That's the IP license. And for all the unique FQDNs, for each unique FQDN, we will be consuming one license. So the fact that they happen to be on the same asset, in this case, doesn't matter. So, if one particular asset is, for example, hosting one website, and at the same time it has number of open ports such as SSH, Telnet, FTP, etc., then it will be we will be consuming two licenses, one IP license and one website license.
Perfect. So thank you, Home, so much for answering the questions in a very detailed and easy manner. So team out here, we are all are available to support you. You are the extended arm of Rich Security. We'll be really glad to come on any customer call and meeting. I am putting my contact details in the chat box. Thank you, Home. Thank you so much. Thank you, team, for your time. And as we said, that you guys are the extended arm for Rich Security. We are, banging upon your capabilities, your relationship in the market. Of course, you are interacting with different customers. We are happy to support you. We are glad to come to the call, whether it is an e-meeting or a call in person. I have dropped my contact details. You guys are more than welcome to connect with me if you require any help. Thank you so much, all the guys who have joined here. Thank you so much, the speakers and all the attendees. Thank you.
Thank you.
Thanks, everyone.